My name is Mark Rees. I'm the CTO with Storiant, formerly known as Sage Cloud, that you may have heard of. Had a name change recently for reasons I won't go into. So we're building cold storage systems for people who don't want to store their data in clouds and would rather store them behind their own firewalls. The systems, cold storage is kind of a new term and not everybody's familiar with it. Probably the thing you may be most familiar with is Amazon Glacier, which provides, oh yes, going to put my logo out there, provides cold storage in the cloud. And I would say that's pretty much our competitor at the moment. But a lot of companies are not interested in storing their proprietary data in a cloud at any costs, and so we saw an opportunity to build systems that they can install themselves. So what we're selling rather, is software, and it runs on commodity hardware, and generally very cheap commodity hardware. And our intent to, one of the major reasons that people are interested in our systems is that the total cost of ownership is extremely low. It's cheaper than storing it in Glacier, and I think in US terms it's about under a cent a gigabyte a month. So how do we build the systems? Formerly, many of us who started the company at Storiant were involved in a company called Carbonite, which provides consumer service to back up in the cloud, to back up your PC or your Mac into the cloud. And we ran our own data centers, and I think there are over 100 petabytes of storage at the moment at Carbonite. And so we learned a lot of lessons about the mechanics of dealing with storage and how painful it can be. And when we decided to move along from Carbonite and do something new, we thought this was really an interesting problem to attack, because it's really very hard to run big storage systems reliably for a long time. And Carbonite, you never know how many customers you're going to have next month, but the operations guy's job was just to roll in new storage, and they were permanently expanding the storage. So scalability was a key issue too. So when we started Storiant, those were the things that we were looking for. It had to be cheap, it has to be very reliable, and it has to be scalable. And that's what we set out to do. We just shipped our first product. It's being beta tested by a bunch of customers at the moment, and we're getting a lot of interest in the market. We use OpenZFS for mostly the reasons that I outlined from our Carbonite experience. We wanted something that could deal with silent failures of the disk, deal with all this kind of corruption that creeps in, bit rot. And when you're in the petabyte scale, those numbers of failures with all the zeros behind them become real. I mean, things fail. And so you better have a mechanism to deal with them. And so ZFS was really the best system out there on the market. Matt did a great job. Thanks, Matt. It really does a good job. We're running it on Linux because in our market, that's what people want to run. And so it was a bit of an immature port at the beginning, and the guys at Livermore did a great job getting it going. It's getting better all the time, as Luke pointed out, and this latest version that's just coming along is looking pretty good. We use it in a kind of limited way, so it's a great big system, has all kinds of features, and we don't use a lot of those features, so I'm not saying that everything works perfectly on Linux, but for the way we use it, which is really for the core usage, it works fine. We don't have a myriad of file systems. We have kind of one file system. We're talking of large amounts of storage. We're putting a couple of petabytes in a rack. So we're dealing with it our system uses an object store interface, so that we tend to be dealing with it in a big scale. It's big chunks of storage at a time. But for that, it's working very well. And that's about it.
Mark, what's the largest single file system that you have?
Well, the single file systems, the way we arrange it, we have a bunch of different pools because it's cold storage, and so we spin all the disks down when they're not being accessed. So we have individual pools that are matched to arrays, and the arrays are of the order of, you know, between 50 and 100 terabytes, something like that. So each one is its own file system, in fact.
What else did you evaluate? I mean, was it just a case of like, wow, ZFS, now we've got a product, or were you looking at something, say, for instance, BTRFS or something like that?
Yeah, BTRFS is kind of not really commercial yet.
Red Hat would argue differently.
Yeah, maybe. But no, we looked at all sorts of file systems. At Carbonite, we actually wrote our own file system. We had unique problems there, and particularly to do with small file sizes, which nobody does a great job on, to be honest. But we had that experience, and we certainly didn't want to go and write another file system. And so we did look for everything that we could find. But for reliability, you know, we couldn't find anything to match OpenCFS.
Any more questions? No? Okay, thanks so much, Mark.